Today class we will discuss about multiplexer. I am Murugan. I am Assistant Professor, Senior Grade, Department of EEE, Sethu Institute of Technology. Now I will give the agenda of today class. The agenda are Introduction, Multiplexer, Symbolic Representation of Multiplexer, Design of 4x1 Multiplexer, Truth Table of Multiplexer, and then Logical Diagram for that Multiplexer, implementation of Boolean function using multiplexer. At last, the conclusion of my part. Now we go for on the introduction part. Multiplexer, it is nothing but many input if feed to your multiplexer. With the help of your selected inputs, it will select which inputs you to feed in the output. For example, you to take multiple input sources are MP3 player, logging systems, laptop sound cards, digital satellite, and then digital cable TV. There are 4 input lines I feed to your multiplexer with the help of selected input source 0, 0, 0, 1 or 1, 1 or 1 zeros. If I to select the help of selected source 0, 0, it indicates your MP3 player logging systems that feed to your multiplexer that produce in the output. The output is nothing but surrounding systems. It is a speaker 1. So which one you to select with the help of selected inputs that feed to your multiplexer and then produce in the output that is in the present in your surrounding systems. If in your selected source, if I to select 0, 1, that indicates laptop sound cards that will pass the input lines through your multiplexer and then it will pass through your surrounding systems. Likewise, 1, 0, if I to pass in the selected source, the satellite digital images that will feed to your multiplexer that forward in the surrounding systems. Similarly, 1, 1, digital cable TV that will feed to your multiplexer that will produce in the surrounding systems. Like this it will happen. Next, what is multiplexer? Multi that indicates multiple or many. Multiplexer means 2 power n input lines make it into a single output lines. Instead of here n that is indicates n selected inputs. In wise that I to represent here input lines 2 power n, selected input lines n and output line is 1. Now I to show a difference between the multiplexer without multiplexers. So in first one that indicates multiplexers. Here if I to pass here no multiplexings, without multiplexings, if I to forward one information to multiple clients means it is not possible. But with the help of our multiplexing, if I feed these systems with the help of your multiplexer, that will possible the one channel bar. That information is present in your 0 line that is feed to your multiplexer that will pass in the bar and the help of demultiplexer it will decode and that information pass to which one we will give. That client system we give that information present in this 0 system. It is possible to present in the help of multiplexer. But without multiplexer it is not possible to work. There is a major drawback present without multiplexing. That's why we go for multiplexing. Now the symbolic representation of multiplexers. So in first I will say 2 over n input line, n that indicates selected input line and one single output. So n selected lines forward for here, 2 power n input lines forward over here and one output line that indicates here. This is a symbolic representation of your multiplexer. Next we go for a design of 4x1 multiplexer. So here I have to represent 4x1 that indicates 2 power n cross 1. Here 2 power n that indicates selected that is not selected. This one is input lines. So 2 power n input lines is equal to 4. That indicates from this we find out n equal to 2. N is nothing but our selected lines. So n selected lines is equal to 2. Input lines are 4. Output line make it as 1. That's why input variables are input. 4 input lines are there. I do represent over the input lines are I0, I1, I2 and I3. Selected inputs are 2. That's why I represent S0 and S1. Output variables 1. So that indicates Z. Next step, for the help of truth table, I formulate the selected inputs S0 0 as well as S1 that also 0. Then the information present in the input line 0 that will produce in the output. If I to select 0 1, that indicates what's the information present in your I1 that will feed to the output. If I to select in the selected inputs 1 0, so if I to select control answers 1 0, that indicates the data present in your I2 forward to your multiplexer and feed in the output. 1 1 I to select in the selected input means what's the information present in the data 3 lines or input 3 lines that forward to your multiplexer and forward in the output path. This is the logical diagrams. S0, S1, both inputs are 0. At that time, the data present in your I0 that forward to your output. In similar manner, this is the logical diagram we followed of it. Next, with the help of implementation of Boolean function using multiplexers, one implementation I do take over my process. In that multiplexer, with the way to design the Boolean functions. So, for example, I to take f equal to x, y, z. That is a 3 variable I to select over here. Summation of 1, 2, 6, 7. I design this function, this Boolean function using multiplexers. In first, I do here x, y, z. These 3 are the variables. That's why I represent x, y, z in the truth table. So, x, y, z starting from 0, 0, 0 to 1, 1, 1. I represent over here. F that indicates the output. That's why 2, 4, 6 and 7. I passed over outputs are 1, 2, 6 and 7. I forward of it. Here, with the help of multiplexers, I do design these informations. In first, I do take 2 power 2 to 1 multiplexer. That indicates 4 to 1 multiplexers. So 4 input that indicates 2 selected inputs, 2 power n equal to 4, n equal to 2. That's it. 2 selected lines were required. The selected inputs I to take in this example as x and y. So I select 0, 0, both x and y. That indicates your output value is f equal to 0 to 1 when your z value is 0 and 1. This implies that f equal to, that is output equal to z. What's the value present in the f that will produce in the output when the input of x and y is equal to 0. Second possible is when x and y are x equal to 0 and y equal to 1, at that time your output value is reciprocal of your input. It's not in your z. That's why f equal to z bar. When you to take x equal to 1 at the time y equal to 0, this indicates your output f equal to always 0. So in your x value is 1, y value is 0, that your output value is always 0. In similar manner, x equal to 1 and y equal to 1, at that time your function f value equal to always 1. This implies that I to design with the help of your 4 class 1 multiplexer, 4 input variables are 0 line, first line, second line and third line. Your 0 line that indicates f equal to z. That's why I have to pass f equal to z. First line z bar, second line 0, third line 1. With the help of selected input as 2 lines x and y. That's why I represent over here as x and y present in the selected inputs, 1 output. This is the implementation part we have to pass in the multiplexers. Why we go for on multiplexer applications? In many applications we have to use for multiplexers. So mainly, without multiplexing, it is not possible for the communication purpose and all. That's why the main applications are telephone systems, satellite, broadcasting, radio, and TVs. In last, I will to conclude my part with the help of conclusions. By using multiplexer based designs, bias and logic gates, minimization is possible. Size of the circuits can be reduced. Because of the size and the bias, minimization is taken in your process, means in similar manner you to indicate the size of the circuits able to reduce. Once the size of the circuit reduce as well as the logic gates are minimizations, then faster response we occurred from the multiplexers based design. From this part, I had to conclude my multiplexers. We had to go for our next session. Thank you.